Hello and welcome to another Blender Geometry Nodes tutorial. And this time, let's create a dungeon maker which can be useful for conceptual level design here in Blender or for custom tabletop map creation. So let's do it. Let's open up Blender. And I'm using version 3.3, which is the latest production build at the time of recording this video. First of all, let's reorganize some of the elements here. Delete default cube and light, hide camera, and create a new collection called My Dungeons. Inside of that collection, let's add a plane with its default size and name it Dungeon. And now we can go to Geometry Nodes tab. With plane selected, create a new geometry node setup. I'll call mine Dungeon Maker. The main idea here is to generate dungeon walls procedurally based on the planes that we create manually. Which means that this should turn later into dungeon corridors. Alright, in Geometry Nodes editor, let's start with Extrude Mesh node. With faces selected in the dropdown, and with offset scale used as wall's height. This value we can add as group input to use in modifier's properties. To better see what's happening with the geometry, we can adjust a few viewport shading settings, change lighting to flat, enable shadow and cavity. Now we can clearly see all the corners of the mesh. And you can notice now that we have some unwanted faces inside of this geometry. But we can remove them with unchecking individual option in the extrude node. Now since we're building dungeons in a tabletop style, we want to remove this top face here. The perfect node for that is going to be the Delete Geometry node. Select faces in the dropdown, and as a selection we can use top value from the extrude node. And as you can see, only the top faces disappeared. Alright, but what we have missing here is the floor. To add it back, we can use join geometry and connect both the extruded mesh and the base geometry. Perfect. Since we have all of that built, we can test how changing the plane in edit mode will change the result. Nice. Now we can add thickness to the wall. And to do that, let's add another extrude node and decrease the offset scale until we are satisfied. Now, extrude node leaves us only with the outer, the extruded faces of the geometry. To get the inner part back, add join geometry node and join this result with the mesh from step before. And we may face one small issue here. If we apply the modifier right now, we can observe that the vertices are not connected. To connect them, let's add Merge by Distance node, which will connect all vertices that are located near each other within the specified distance. And now vertices are connected. But beside that, there are a few other issues, so let's fix them real quick. Let's enable face orientation. And as you can see right now, there are some overlaps and wrong face orientation highlighted in red. Face direction can be fixed with Flip Faces node, which we will put right here. And everything turned blue right away. As for the overlaps, let's add Mesh Boolean node right before merging by distance, which will unite all the faces. Awesome! So this is a simple base logic for wall generation based on the planes. Now we can add few additional options to group input, like this offset scale value and this individual option, whether to use connected or quad walls. And now we can add a frame to group all of these nodes, to have everything well organized. Alright, now before we switch to material building and instancing interior within the dungeon, I want to show you how to make this dungeon out of procedural grid. So since we want to have this as a feature, let's add a switch node with base geometry connected into false socket. Now, this switch boolean can go to group input, and when we toggle it, we can see that everything disappeared. And this is because we need to have something connected into the true socket. And this something is going to be mesh primitive grid. Now, when we change number of vertices to 2 and size to 2 meters, we can see a simple unsubdivided plane, which is what we need. Let's create a grid based on the parameters we input. So in the group inputs, let's add 3 integer fields for cell size, grid size X, and grid size Y. And also let's set defaults for all of them. Minimum and default values should be set to 1. Now let's make these size X and Y of the grid to be step-based or cell size based. For this, add a math node, multiply cell size by grid size X and put it into size X of the grid node. And do the same thing for the size Y. Now, with these values, we can control how many cells we have with the specified cell size. But it is not subdivided yet. To subdivide this box geometry, add a math node. Take the grid size X, add 1 to it, and plug it into vertices X, and do the same thing for vertices Y. As a result, we'll get subdivisions of this grid based on the number of cells on X and Y axes. And we can observe this in wireframe mode. Perfect. But we have no walls here at all. We can add those with checking individual here, but those are not going to be the corridors. Instead, let's delete some random cells in this grid. So add delete geometry node after the grid, select faces in the dropdown. And for the selection, we'll use random value node with boolean set as data type. As you can see, we already have the result. Using seed and probability options will randomize this grid. However, probability works a bit different from what we expect. What we need is that when we set probability to 1, all of the cells will appear. So we can change that with mapRange node and switch minimum and maximum values for this probability setting. Now we can test the randomization options for the procedural corridors. Let's add probability and seed to the group input. And since we're getting a lot of inputs in here, it would be nice to organize them by categories. For me, the best way to do this is to add a string inputs with no connections and names for each category. And in modifiers properties, we can specify names for those groups. Now, since we've done that, let's rename all of those input values to not get confused later. As for the nodes, let's add those to a frame with Ctrl J. Perfect. The next step is to apply materials for this paper box lookalike dungeon. So let's create 2 materials, one for the walls and one for the floor. And we can create them in the materials section of this object, but they won't be applied. To properly apply materials in geometry nodes, we need to use setMaterial node. So let's add these for walls and for the floor, with materials selected accordingly. Good. Let's move to Shading tab and start making materials. First, let's make walls. So I want to use realistic textures for this. And the best place to find free realistic textures for PBR materials is Polyheaven. They have lots of textures, HDRI, and models. So I've picked some textures in 2K resolution to use for my project. Drag and drop diffuse texture into the editor. Let's preview this one right here. It is called Rough Block Wall. Now, even connected to the base color, it doesn't seem to work. The thing is, we need to specify how to apply this texture to geometry. So with Node Wrangler add-on enabled, select Texture and press Ctrl-T. Texture coordinate and mapping nodes appeared. Let's change vector from UV to object. The texture became visible, but it is stretched. To fix this, let's rotate texture in the mapping node. I've found that 90 degrees on X axis and 33 degrees on Y axis work best. However, we can adjust these values as needed. Let's also add a value to control the scale of the texture. As for me, 0.7 or 0.8 work best. Now, the next thing we can do to customize this texture is to add some moss. And we can do this with Ambient Occlusion node. If we preview this node, we won't see the ambient occlusion until we switch to Render mode in Cycles engine. And when we've selected those, we can see all those shadows in the corners. To make this effect stronger, we can adjust black and white values with Color Ramp node. Now we can use this as a factor in Mix RGB node, where our diffuse texture will go to color 2 and color 1 is going to be that dark green color representing moss. Now let's connect this Mix RGB into Principled BSDF. And import the rest of the textures for this material: roughness, normal map, and displacement. For these three, we need to make sure to set color space to non-color to avoid unnecessary shading defects. And let's quickly connect textures to their corresponding sockets with same mapping node used as vector. For a normal map, we need to use two additional nodes, normal map and bump node. As for the displacement, plug it into the height socket of the bump node. After connecting all the textures, we can see that normal strength can be reduced at least twice. Yeah, we get the level of details we want. Now let's fix that problem with the top faces. Unfortunately, we cannot fix this from this material, so we're going to create a new one. Let's duplicate walls material and rename it. And in geometry nodes, add another set material node right after previous wall material. Of course, we need to reset the rotation for that new material and specify the faces that we need this material to be applied to. Faces that are pointing up or down. So let's take normal input node. Separate X, Y, Z, since normal gives us directions on X, Y, and Z, and use compare node to check if Z-axis is not equal 0. The result of this compare is going to be the selection for the wall's top material. Now let's work on floor material. The process is going to be exactly the same at the beginning, just with different textures. I'm using large sandstone blocks from Poly Heaven. Add mapping nodes and adjust texture scale. Since we have huge plane area covered with a seamless texture, let's break it with some sand. Let's add another Principled BSDF. and mix both of them with Mix Shader node. Factor should be driven by Musgrave texture. We can preview this texture and adjust parameters and levels with Color Ramp. For the second principal BSDF, I'm going to use Coast Sand texture with its own mapping nodes. Now let's quickly connect the remaining textures for this material, and we're good with the floor. Now it's the most exciting part of this geometry node setup, adding interior to this dungeon. So let's create another collection called Assets with sub-collections. I have pre-made a few models for dungeon interiors to not make this tutorial too long. So I have a couple of assets here. All of them have pivots at 0 and translated according to their position on the 1 meter in height wall. One door asset, 2 types of blocked windows, a chest, 2 types of pillars, and some barrels. These assets are grouped into a collection called Wall Decor. Also, there is a torch with separated components: torch itself, fire, and point light. These items have separate collection called Wall Lights. And the last but not the least, Floor Decor collection, with one asset, Hatch. Cool. Let's hide all these assets from the viewport and from render, and return to our dungeon. So the first thing we want to do is to put all of those pillars, door, and windows on the walls, and specifically on these inner faces. That means that we want to have points on those faces. And we have a perfect node for that, Mesh to Points. So let's find this node and plug the geometry we want to convert to points into the mesh socket. Select faces in the dropdown, and to view these points we can join them with the rest of the geometry with Join Geometry node. Like so. Now let's replace these points with our Wall Decor assets. Add instance on points node right here. Once we've added this node, points disappeared, because we need to have objects here in this instance socket. So let's drag and drop the whole Wall Decor collection and plug it into instance. Looks like a total mess. To make it right, we need to check Pick Instance checkbox to select only one object from that collection. Also, in the collection info, select Separate Children and Reset Children checkboxes. Looks better, but all the instances are too small and placed too high. Let's fix the scaling first. As you remember, assets were designed for a 1 meter wall, so we can use wall's height value from the group input and plug it into the scale socket of instance on points. As for the location, Since points are generated in center of each face, let's translate all those assets down half of their height, which means 0.5 meters. Now the rotation. We want instance to get the direction based on the wall it is located on. For this, let's get a normal of that face. There is an excellent node, transfer attribute. Let's add this node. We want to get normal, so let's select vector in the data type dropdown. As a source, we're going to use geometry that we use as points for instances. And the attribute itself, normal input node. Now we have this normal as an attribute right here, so let's use it for calculating the rotation of each instance, with align Euler to vector node. Plug this normal attribute into the vector socket, and the rotation output into the rotation of instance on point node, as well as select Y as the local axis of the object. Everything just got hidden inside of the wall, so we need to rotate objects 180 degrees. And we can do it either for each object in the collection, or use already added transform node, and rotate objects 180 degrees on Z-axis. Now we can test how it will work with different variations of dungeons. As you can see, when we extrude edges in the source geometry, objects populate automatically on each face. And there are a few additional things we can do to improve this. The first one, we may want to change objects on their positions. So we have this instance index socket with which we can specify index of the object in the collection, and even add a random value node with integer selected as a data type. And there are multiple use cases for this. We can either specify exact index of the object, like 0, or a range of indexes from 0 to 3. But when we put 100, for example, random value node will keep selecting only those items that are in the collection. And with the seed option, we can randomize items picked for the points. Another option, the probability of instance of an object on the wall. Add another random value node with boolean set as data type, and plug that into a selection socket. We have probability and seed options on whether object will appear on the wall. Now it may happen that we decide to make some small walls at corners, for example. We don't want to have large window on that wall, so we can include that in the selection of points for instances. But we need to get the size of that wall and specifically how wide it is. So we want to transfer another attribute, float this time. As for the attribute, it is going to be face area. Source is going to be same geometry. To calculate how wide is that wall face, we can divide this face area attribute by wall's height. Now we can compare the result of this against some value, which will state if the width of the face is greater than that value, then put an instance on that face. And by multiplying these two selections, we will get a combination. Yeah, and it works. Now let's quickly reorganize all of this and add required values to group input. But it's not a dungeon if there are no torches on walls. So let's add those. The process is very similar to what we've just done. Add mesh to points node. Connect the same mesh as we used for wall decor instances. Add instance on points and join that with the rest of the geometry. Drag and drop collection with the wall lights and plug it into the instance socket. And we won't check separate children and reset children options since we want all items from the collection instanced as they are. For the rotation, we can use the same output value as for wall decor. And of course, use transform node to rotate the object 180 degrees on Z. What we don't want is for a light to be instanced on same locations as wall decor. So we can use the same probability output value and compare it against a value. Specifically, it should not be equal to 1. And here we are. We can adjust probability of wall decor and wall lights with a single slider. Now, since we have point light included in wall light collection, we can go to render view and adjust the power of that light or even color if we want. Additionally, for light selection, we can add another random value node with Boolean and multiply it by existing selection. And we will get additional probability setting for the light. Okay, the last item for this setup, floor decor. Let's add those hatches with the same method. Convert mesh to point. This time we will use floor as a mesh. Add instance on points and join that with the rest of the geometry. Drag and drop collection with floor decor elements. Add a random value with Boolean data type for the selection. Select separate children, reset children, and pick instance options, just in case we want to add additional items to this collection. We can also randomize the rotation of the hatch instances on Z-axis. Add combine XYZ node and plug it into rotation. Add a random value node with integer data type and range from 0 to 3. And multiply it by 90. Add another math node and convert this value to radians. And plug it into Z socket of combine XYZ node. And it looks like this is it. You may add additional models to these collections to have more different elements, play with procedural settings, and instances probability and seed. So I hope you enjoyed this tutorial. Please like and subscribe if you did. As always, you can get this project on itch.io. Thank you very much for your attention and have a great time of the day. Take care. Bye-bye.